Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to talk about higher order constructs, reflective. Now let us try to understand the concept of higher order components, that is a second degree model or a higher order models. Say for example, the price, which is a construct, is captured by some measured variable. Service quality is captured by some measured variable. Personnel is captured by some measured variable. And similarly, the service cap. Now, all these constructs combine to make one more higher order construct, that is a satisfaction. So the satisfaction is a combination of price, service quality, personnel, and service caps, which are a construct. So these are all known as a first order, that is a lower order components, and these are known as a higher order components. Now, depending upon the arrows which are coming inside the construct or going outside the constructs, we name the model as a reflective model or a formative model. So we start with the first one. The nomenclature goes this way, that we first give the name for the lower order. So you can see here in this case, the arrows are moving outside and therefore it is a reflective. Similarly, for higher order, again the arrows are moving out, therefore it is a reflective. This is a type 1 model. If we talk about second model, you can see arrows are moving out, but in case of higher order, the arrows are moving inside, and therefore this is a type 2 model, which is a reflective formative model. Then we talk about the third case, in which arrows are moving inside in the lower order, and therefore it is a formative one. And in higher order, arrows are moving outside, therefore it is a reflective. So it's a formative reflective type 3 model. In fourth case, that's a type 4. In lower order, arrows are moving inside. In lower order, formative. And in higher order also, the arrows are moving inside the construct, and therefore it is a formative. So if we talk about reflective, that's a type 1 model. So here, lower order construct is reflective and higher order construct is reflective. Now, how to report the higher order constructs? So first, report the reliability and validity of lower order constructs, and then report the reliability and validity of higher order constructs. Now, let us try to understand this concept on SmartPLS-4. We have started our lecture series with this example where job satisfaction of an employee is affecting the staying intention of an employee. Environmental perception is affecting the staying intention of an employee. Organizational commitment is affecting the staying intention of an employee. And behavior of co-workers is affecting the staying intention of an employee in the company. Now I want to say, let us assume that job satisfaction, environmental perception, and organizational commitment, they all form one higher order construct, which we'll name it as HOC. This is just a normal, you can say, an assumption, which we are saying that these three constructs will combine together and form one HOC, that is a higher order construct. Now, how we can include the HOC in our model? Let's see. First of all, let me drag this and change this shape. I'll disconnect all these lines. 1, 2, and 3. Now from here, pick up the latent variable. And name it as HOC. Enter. Now, you can see here, at present, job satisfaction, environmental perception, organizational commitment, they are all formative. Now, how we can make it reflective? Select it and make it reflective, and this also reflective. So my lower orders have turned to be reflective. Now this is an HOC. To make this also reflective, I'll pass the arrow like this, HOC, and HOC. Now I will connect HOC with the staying intention. So you can see here that HOC is still red. The color has not changed. Now that's a problem that's a flaw in the design. To run HOC, we have to give some latent variable. So SmartPLS requires that all the lower order constructs, the measured variable of all lowered order constructs are loaded on HOC. Then only the model will run. So what I'll do, job satisfaction, I'll pick up its all the measured variable JS1, JS2, JS4, and I will load it here. Then I'll pick up EP1, EP2, EP3, EP4. I will load it here. Then I'll pick up OC1 to OC4, OC1, OC2, OC3, OC4, and I'll load it here. Now, you should understand one thing, that whenever you include the higher order constructs and the measured variable of lower order are loaded on HOC, the arrows must be in the same direction. It means that if this is reflective, then this also should be reflective. This is not possible. Say for example, if I invert the selection and I make this formative, so my lower order is reflective and the measured variable on HOC are formative. This is not possible. So you have to keep the direction of the arrow. You have to keep the arrows in the same direction. Now, how to do the reliability and validity of such model? We can directly test the reliability and validity of lower order constructs such as job satisfaction, organizational commitment, environmental perception, co-workers, and staying intention. Directly we can do from here. See the lower 1, 2, 3, 4, 5, and they are reflective, and therefore reliability and validity can be tested very easily. Okay. Yeah, this one. As they are reflective construct, we will use average variance extracted, composite reliability, and Cronbach alpha. Also, we will consider the Forner-Larkin criterion and HTMT for the discriminant validity. Now, how we can do this? Let's see. We'll go in calculate, PLS-SAM algorithm, start the calculation. And you can see the results are ready. Now I'll click on open the report. First of all, I'll directly go into the out loadings and I'll try to figure out which statements are having less loading. You have to completely ignore HOC here at this level. You have to only see the values of lower order, that is the measured variables of lower order. All are in green, so therefore things are, you can say things are good here. Now we already know that what is a criterion for this to turn green. If this value is more than 0.708, then this will turn green. I will request all my viewers to kindly refer my previous videos to understand the flow of this entire lecture series. The next thing which I have to do is I'll go in construct reliability and validity. Okay, one thing more. At any moment of time, if you feel that any of the measured variable, its explanatory power is less and you want to delete it, make sure that if GS1 is deleted from here, simultaneously GS1 should also be deleted from the HOC. Or if you feel that, say for example, let me try to find out the lowest one here. The lowest one is points JS4. If you delete JS4 from here, simultaneously JS4 should also be deleted from higher order construct. Now, next thing which you have to see is the construct reliability and validity. Here also you have to completely ignore the values of HOC. These values are to be ignored. Now, you will check the reliability and validity. Cronbach alpha is given, composite reliability is given, composite reliability rho C is given, average variance extracted is given. The criterion remains same for what we had did in the lower order constructs. Everything remains same. So this should be more than 0.7. Average variance extracted should be more than 0.5. This should be more than 0.7. You can also get the bar chart from here. Now, the SmartPLS-4 SmartPLS-4 is having a feature that you can customize this chart and you can even change the threshold limit. The threshold limit which has been specified is 0.70. If you change this 0.60, you can change from here 0.60. But let us keep this as point. If you want, you can make it 0.8 also, 0.80. So these are all above 0.80 and therefore things are quite good. So I'll keep it 0.70 only. Now you can click on average variance extracted. You have to completely ignore HOC at this stage. The new features of SmartPLS-4 allows you to copy the chart from here directly into your Word file. Now we will check the discriminant validity. Click here, Forner-Larkin criteria. Here also completely ignore the values of HOC. Diagonally, you have to see that these values are highest in corresponding rows and columns. Let me try to explain this. We already understood this thing in the lower order construct, but let me try to explain this once again. I'll copy this in Excel. Now the first thing which I have to do is I'll delete HOC from here, even HOC from here. We cannot consider the values of HOC from here. I'll explain the reason later on. Now, these values which are there, the diagonal value, these values should be highest in corresponding column. Say for example 0.836, this value should be highest in corresponding column as well as corresponding row. If the value is highest, then we have achieved the discriminant validity. So this is a Forner-Larkin criteria. Now let us see what the that is Htmt ratio is, heterotrait monotrait ratio. Here also the HOC, we will have to ignore the values of HOC. And all these values which are there, they should be less than 0.85. I'm repeating again, in case of HTMT, these values should be less than 0.85. Now you can see here, this HOC value point is 911, but we have to completely ignore it. So HOC column wise and row wise is to be ignored at this stage. All others are green. That's quite good. Now the next thing which we have to see is the collinearity statistics. All these values should be less than 3. If it is there, then we can say that we have achieved the reliability and validity of the measurement model, the outer model. Now when you will click on inner model, you will see that the values of HOC is 1111. This is completely wrong here because you cannot take the values from here. I'm again repeating, don't take HOC, higher order constructs value, that is reliability and validity cannot be tested at this stage. Now to test the reliability and validity of the higher order, SmartPLS-4 is having a fantastic feature. You go here, create the data file. Now, as soon as you click on it, it will ask that you want to include the manifest variable or the latent variable scores, outer model scores, inner model scores, and others. Let me click on others. So it can give you the case index if you want to include it. So this latent variable score is one composite score per factor, per construct. These are the latent variable scores. This latent variable scores works as a proxy for the construct. It will give you one composite score. So if you want to include the measurement model, you should also consider the manifested variable. Otherwise, you don't need to include it. So it is giving me that HBAT-SAM1 is the file which is already existing because I had run this thing previously. So I'll rename it and I'll say I'm going to use HBAT-SAM2. Create the new file, create. Now this file with the latent variable score is created. Go and edit. And now you can select the data set from here. So the data set is HBAT 1 derived from PLS results 1. I will activate the file. Now if you go on the fag end of this, you can see that all the latent variable scores, the composite scores, have been saved automatically. In the previous version of this, we have to save this in Excel, and again we had to import it and load this. But the SmartPLS-4 is having a fantastic feature where you get the latent variable scores in the left hand side menu. Now what we have to do, let's try to understand. Job satisfaction, its composite score is available. You can see here. Environmental perception, its composite score is available. Organizational commitment is composite score is available. So what I'll do, first of all, I'll remove this. I will also remove all the other, this EP1, EP2, EP3, they are also to be removed. So I'll delete this entire HOC. Now I'll pick up the new latent variable from here. And again, I'll name it as HOC. Now, what I'll do is I'll load organizational commitment, job satisfaction, and environmental perception here. So, OC, then environmental perception and job satisfaction. The latent variable scores are loaded here. Done. So we are not able to see the names of this latent variable. What I'll do, I'll double click on it. Now I'll remove it. Remove the LV scores, and now you can see environmental perception is there. Apply. Job satisfaction. Apply. Organizational commitment. Apply. I can increase their sizes, the size of the boxes. I can increase the box from here. Simply drag it. Now you can see that my HOC is ready. But still, I have to connect it. So I'll connect HOC with staying intention. Make sure that the arrows are moving outside the HOC. The reason is, if you recall, our original model was reflective. See, this is formative. Make sure that it's a reflective HOC. I'll also connect. So my model is ready. Now I have to, first of all, what I'll have to do is I'll have to test the reliability and validity of HOC. See, staying intention, reliability and validity is already tested in the first stage. Co-workers, it is already tested in first stage. But what about this? It has not been tested. So I'll go and open the report. And I'll go and construct reliability and validity. Now I will have to see only the values of HOC from here. So you can see the values are there. The SmartPLS-4, you don't need to run the algorithm again and again. Once the connection has been established, it will start giving you the results directly. So I'll click on construct reliability and validity. Make sure at this moment of time, in the second stage, you are only testing the reliability and validity of the second order. That is a higher order. You should not test the reliability and validity of the of the first order. Now, what is a basic reason for this? Let's try to understand why we are going with this approach. The reason is that when we run the algorithm, the reliability and validity of HOC will be based on this parameters, for this, the lower order measured variables, EP1 to OC4. But actually, in reality, the reliability and validity should be based on this 0.476, 0.792, 0.831. But the software reports on the basis of this. So this is wrong. And that's the reason we are going for the second stage, where we only test the reliability and the validity of the higher order constructs. That is the reason. Okay. So you can report the bar charts from here. Composite reliability, composite row C, average variance extracted. The criterion remains same, that this value, Cronbach alpha should be more than 0.7, this should be more than 0.7, and average variance extracted should be more than 0.5. Now you can see here that there is some, you can say the values are less than the threshold limits, but for understanding purpose, we will proceed further. Now you should click on discriminant validity and directly go into the Forner-Larkin criterion. Diagonally, these values, you will only see the HOC value. Its value should be higher in corresponding column and corresponding row. If it is there, then we have achieved the discriminant validity of higher order construct. Then you can click on HTMT, heterotrait monotrate ratio. The HOC value should be less than 0.85. Should be less than 0.85. If it is less than 0.85, which is a desirable, the specified limit is 0.85. If it is less than 0.85, we have achieved the discriminant validity. Once we have achieved the reliability and validity of higher order models also, now we will run the bootstrapping. So for this, you can go and calculate, activate the bootstrapping. Now why it is necessary, let us understand. First of all, the reliability and validity of the outer model for lower order constructs was done. Then the reliability and validity of higher order construct is done. Now we want the statistics related to the structural model. Measurement model is over. Now we want the statistics related to the measurement model. So what I'll do, I'll go and calculate, activate the bootstrapping, start the calculation. Open the report and you can click on path coefficients for the direct effect. If these values are less than 0.05, we can see that these path coefficients are significant. Moreover, this can be further confirmed by bias corrected, confidence intervals bias corrected. There should not be, the zero should not be present in this two interval. If zero is present, it means that these path coefficients are not significant. See, you can see here from positive to positive, the numbers are from positive to positive. But if any path coefficient is having this range from negative to positive, it means that the zero is present in between this range and this path coefficient is insignificant. But you can see all of them are significant. You can also get the specific indirect effect from here, where HOC, higher order construct affecting the co-workers affecting the staying intention, its value is 0.033 and its value is less than 0.05, and therefore the specific indirect effects are also significant. Now to report the R square and F square of this model, what you can do is, again you can go back, calculate, PLS-SAM algorithm, start the calculation. You can go and open the report and directly click on R square, where you can get the R square of all the endogenous constructs. You can report R square bar chart, R square adjusted bar chart. From here, you can report F square statistics, that is the effect size of the model. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series, where I have already uploaded the threshold limits of R square, F square in lower order constructs. Then you can report the collinearity statistics from here for outer model and for inner model. The value should be less than 3. Now let us make one change here. You can see here that if I want to report this model, it is only giving me the path coefficients. But I also want to report the p-value here. So I'll go and calculate, bootstrapping, start the calculation. And you can see that path coefficients and its p-value is there. Normally, we run the PLS-SAM algorithm for the measurement model, and for the structural model to get the p-values, we run the bootstrap. If it's not exhibiting the values, you can go here and you can activate outer weights loading and p-value, outer weights loading, t-value, whatever your requirement is. You can specify from here. Now, at present, our HOC is exogenous. What will happen if I convert this thing into endogenous? So first of all, let me disconnect this line. And try to connect this. Now immediately, the SmartPLS will give me the error. The error is that the model is in loop. You can see here, staying attention affecting HOC, HOC affecting co-workers, co-workers affecting staying attention. Such model cannot be solved by SmartPLS algorithm. So I'll disconnect one of the lines and try to figure out that if I convert HOC into endogenous, what are the results? So I will again go back and open the report. The path coefficients results are there. And specific indirect effects are also there. So here now the co-workers are affecting the staying intention affecting the higher order construct. So for more videos on SmartPLS-4, kindly subscribe to my channel. You can also follow me on LinkedIn and Twitter. Please refer my playlist in which I already uploaded many videos related to SmartPLS-4. Don't forget to press the like button.